Questions 21 through 25 on the 2006 Grade 8 Gauss Math Contest. Natalie has some quarters, dimes, and nickels. The ratio of the number of quarters to the number of dimes to the number of nickels that she has is 9 to 3 to 1. The total value of these coins is $18.20. How many coins does Natalie have? 9 to 3 to 1. Now, this represents the ratio of the quarters to the dimes to the nickels, correct? Now, that's just a ratio. That doesn't tell me how many. So what I have to do is first introduce an unknown. So I'm going to call it x. So the ratio is really 9x to 3x to x. All right? So that is what I'm going to first do in this question. Next, we have to look at the total, which is $18.20, and I'm going to convert that to cents, so 1,820 cents. And that equals 25 cents times the number of quarters, plus 10 cents times the number of dimes, plus 5 cents times the number of nickels. Correct? So, there you go. This is the equation we have to solve. Now, we know that the number of quarters is 9x. The number of dimes is 3x. And the number of nickels is just x. And that is 1820. So if you add all this up, you multiply this out, you get 225x plus 30x plus 5x is 1820. And this whole side totals 260x, and that's of course 1820 again. And if you divide through, you get x is equal to 7. So coming back here, that means there are 9x quarters, and 7 is equal to x, so that means there are 63 quarters. The number of dimes, well, 3x, x is 7, so 21 dimes. And the number of nickels is just x, which is 7. So the number of coins, you total all this up, 63 plus 21 plus 7, and that is equal to 91. 91 coins. So number 21, the answer is D. The 8 people at a party shook hands exactly once with each other, with each of the others before the 9th person arrived. The 9th person then shook hands with some of these 8 people. A total of 32 handshakes took place. With how many people did the 9th person shake hands? All right, several ways of doing this question. I'm just going to label the first 8 people, A, B, C, D, E, F, G, H. Each of these letters representing one of those 8 people. And then it won't take us that long to figure out the number of handshakes. And I like to do it in this complete sort of thorough way to help explain. So A first shakes hands with B, then with C, then with D, and so on, right? E, F, with G, and H. So how many handshakes took place here? Well, 1, 2, 3, 4, 5, 6, 7 handshakes for A. So A is done. We don't need to include A anymore. So now we talk about B. B already shook hands with A, so we don't have to include that, but we have to include B shaking hands with new people, C, D, and so on. And once you do that, how many handshakes? We got 6 more. In a very similar way, move on to C. C already shook hands with A and B, so we don't need to worry about that, but we need to look at CD, CE, CF, CG, and CH, the new ones, right? So that's 5 more handshakes. And you get the hang of this, right? For D, same thing, DF, DG, DH. That's 4. Keep going here. E, EF, EG, EH. That's 3. F is G, F is H. That's 2. And then finally, the very last one, G with H. So, based on the question, 8 people at a party shook hands exactly once with each of the others. This is this whole scenario. And if you add all these up, you get a total of 28. All right? So a 9th person comes along a ninth person, and he or she shakes hands with some of them. Okay? And when it's all said and done, there's a total of 32 handshakes. Well, 28 of them have already been done, so that means 32 minus 28, which is 4, is how many handshakes that ninth person must have had or done. So that's the answer. So number 22, the correct answer is B. In the diagram, the points are evenly spaced vertically and horizontally. The segment AB is drawn using 2 of the points as shown. The point C is chosen to be one of the remaining 18 points. For how many of these 18 possible points is triangle ABC isosceles? So for a triangle to be isosceles, the criteria is that 2 sides have to be the same length, right? Well, one side has already been given to you, and that's AB. So what we need to do is first figure out what is the length of that side. Okay, well, that shouldn't be too much of a problem. Since we can really use any kind of distance, we'll just call this 1. Each of these units are 1 apart. So that means from here to here is 2. So AB using isosceles triangle, well, we don't know it's isosceles, so we'll just use the right triangle method, which is Pythagoras. It'll be 1 squared plus 2 squared is equal to AB squared. And that means AB is root 5. So our criteria is to get one other side equal to root 5. Okay, that's pretty much the only thing we need to do in this question. Try to figure out one other side that has a length of root 5. Okay? Or a better way, if you don't want to do certainly don't want to do the Pythagorean theorem over and over again, so just, you can use it kind of like 2 down, 1 across, or 1 down, 2 across. You see what I mean? Each of those would give you a root 5. Like this is 2 down, 1 across, and that's root 5. Or 2 across, 1 up, that's root 5. You see what I mean? And as we do this, you'll get an understanding of how this works quickly. All right, let's go for it. First thing I'm going to do is just start with this guy right here. Okay? And I'm going to be looking at the length of A to that point. So my first point, of course, is right here. That's my first candidate. And I'm going to call that C. So what I'm doing in this first scenario is just looking at the length of AC. And I've got to get AC to be root 5. All right? Well, here we go. Okay, first one, if I do that, will it be root 5? No, it will be 2, right? 1, 2. So that's not a candidate. Cross that out. How about this one? Well, obviously not. That's just 1. Okay, cross that out. How about this guy here? Well, again, that's just 1. That's not going to be root 5. And this one, same thing. That's going to be 1, 2. So that's not a candidate. So very quickly, we eliminated those. Let's go to this guy. If I draw a line from that to that, is that going to be root 5? Yeah. You don't have to do Pythagoras. It's 1 down, 2 across. So that's a good one. Circle it. That works. This one. Nope, that's not going to be root 5. That's going to be 1. That's not going to be root 5. But this one will. Right? Because it's 1 down, 2 across. So that's good. You see how we're going through each one by one? It won't take that long either. All right, now we're down to this guy, all the way down here. That's 2 down and 2 across, so that's not going to be root 5. This one here, that's easy, that's just 2, so that's not root 5. How about this one? Yes, indeed. That is 2 down and 1 across. That is indeed root 5. Circle that one. And this one, nope, that's 2 down and 2 across. That's not going to be root 5. Okay, now we get to the bottom row, and that's not going to be root 5. These are going to be all going to be longer than root 5 for obvious reasons, right? That one, this one's going to be a full 3. That one is going to be longer than root 5, and so will that one. So very quickly, we did this one. and we got three possible dots that we could use as a potential C to create a triangle ABC that is isosceles. All right? Now you say, well, okay, that completes it, doesn't it? Not really. Watch what happens in the next scenario. Now we're going to do the same system, but this time when I connect it, you think, well, isn't that the exact same thing? No, because now we're looking at BC. We're looking at the length of BC. Here we looked at the length of AC. Here we're looking at the length of BC in this scenario right here. So it's not identical. Well, the very first one, let me do it again here without making this messy. This is my candidate for C. And let's look at BC. And remember, we want the length to be root 5. Well, is it root 5? Sure. It's 1 across and 2 up. So that first one works for BC to be root 5. All right? And this one, of course, was AC equal to root 5. All right, we got one. How about this one? Will BC be root 5? No, it'll be 2. So that's no good. How about this one? Well, BC will be basically 2 up and 2 across, so it won't be root 5. So that one's no good. How about this one? No, that's going to be way too big. 2 up and 3 across. So that one's no good. All right, so as you can see, you get the hang of this. All right, let's use this one. BC, nope, looks like it's too short. Here, BC is just 1. If this is C, nope, too short. So cross those out. This one, let's see here. This one looks promising. 1 up and 2 across, indeed. So we got that one. Okay, and then this one, that's going to be too long. It's 1 up, but it's 3 across. So that won't be root 5. This one, that's only 1. So that's no good. This one, again, only 1. No good. This one is 2. And this one is 3. So those are pretty easy to figure out. All right, final row. Here we go. This one, nope, that's not root 5. That's just 1. That's not root 5. That is, it's 1 down and 2 across. So we got another one. And finally, this one is 1 down, but it's 1, 2, 3 across. So that's not going to be root 5. So we got another 3 here. So the total, 3 plus 3 is 6. So as you can see, if you're thorough, you can get all the right ones. So 6 of these dots will be able to make an isosceles triangle. So number 23, the answer is A. In the diagram, the grid has 150 rows and 150 columns, numbered 1 through 150. In row 1, every box is shaded. In row 2, every second box is shaded. In row 3, every third box is shaded. The shading continues in this way, so that every nth box in row n is shaded. Which column has the greatest number of shaded boxes? So how do you approach this question? Well, first let's talk about this. In column 1, how many shaded boxes are there? Well, just an R diagram. I'm obviously not going to draw out all 150 columns and 150 rows. Just in this diagram that you see, well, there's only 1. In column 2, there's only 2 shaded boxes. In column 3, seems like there's 2. Column 4, there's 1, 2, 3, and so on, right? Now, what's the story here? Like, why or when is a box shaded? A box is shaded when it is a multiple of the row number. That is the key to understanding this question. So, for example, in row number 2 right here, the boxes that are a multiple of 2 are shaded. So this is the second box, it's shaded. This is the fourth box, that's a multiple of 2, it's shaded. This is the sixth box, which is a multiple of 2, it's shaded, and so on. This is the eighth box. In row number 3, boxes that are multiples of 3 are shaded. Third box, sixth box, and so on. In row number 4, boxes that are a multiple of 4 are shaded. Fourth box, eighth box, and so on. So you get the idea, right? So what we have to do is figure out which column has the greatest number of shaded boxes. And how do you do that? You figure out which column has the greatest number of divisors. And if you can do that, that will tell you which column has the greatest number of shaded boxes, because every divisor represents a shaded box. So the column that has the greatest number of divisors will have the greatest number of shaded boxes. So let's go through each answer choice and figure out the number of divisors. So 144. 144 is what? It's 2 to the power of 4 times 3 to the power of 2. Now, how do you figure out the number of divisors? Well, you take the exponents and you add 1 to each of those exponents and you multiply them. So 4 plus 1 is 5, multiplied by 2 plus 1, which is 3, and that gives you 15 divisors. All right, let's keep going. 120 is my next answer choice. What is 120 broken down into prime factors? It's 2 to the power of 3 times 3 to the power of 1 times 5 to the power of 1. Now we have to figure out the number of factors. Again, same thing. Take the exponent, add 1, so 3 plus 1 is 4. Then you take the next exponent, 1, add 1, which is 2. Then you take the next exponent, 1, add 1 is 2. And then you multiply those. 4 times 2 times 2 is 16. So 120 has 16 divisors. Next answer choice is 150. What is 150 in prime factorization? It's 2 to the power of 1 times 3 to the power of 1 times 5 to the power of 2. So again, same system. 1 plus 1 is 2 times 1 plus 1, which is 2, times 2 plus 1, which is 3. So 4 times 3, 12. So 12 factors of 150. Now 96 is my next answer choice. What is 96? It's 2 to the power of 5 times 3 to the power of 1. So that would mean 5 plus 1 is 6. 1 plus 1 is 2. So that means that's 12. 12 factors of 96. And finally 100. 100 is, in terms of prime factors, 2 to the power of 2 times 5 to the power of 2. And same system, 2 plus 1 is 3 times 2 plus 1 is 3, 9 factors. So therefore, which of these numbers has the greatest number of divisors? Well, it would be this one right here. It has 16 divisors. And therefore, the answer to number 24 is 120. Since that number has the greatest number of divisors, it will have the greatest number of shaded boxes because each shaded box represents a divisor. Number 24, the answer therefore is B. In the diagram, the numbers from 1 to 25 are to be arranged in the 5 by 5 grid so that each number except 1 and 2 is the sum of its two neighbors. Numbers in the grid are neighbors if the squares touch along a side or at a corner. For example, 1 has 8 neighbors. Some of the numbers have already been filled in, which is the number that must replace the question mark when the grid is completed. So first, let's just explain the neighboring system. Look at 1, right? All the numbers that surround it are technically its neighbors because they share a side or they share a corner. So for example, number 1 shares a side with 5, right? So that's a neighbor. But number 1 shares a corner with 6, so that's also a neighbor. So that is how they're getting these numbers. So for example, let's talk about this. 1 and 2 are the ones that are not included in this system. They tell you that except 1 or 2, but everything else is included. So how did we get a 3? Well, it's 1 plus 2, right? These two guys. How do we get a 4? It's 1 plus 3. We added 2 of its neighbors. How do we get a 9? Well, it's 1 plus 8. two of its neighbors. See what I mean? As long as a number surrounds a number, it's called a neighbor. So, for example, 25, what are the neighbors of 25? Any number that surrounds it. So this number, and this number. You see what I mean? So I just want to explain that. Hope you understand that neighboring system. Okay, now our task is to complete this diagram. So let's go for it. So I've blown it up a little bit, and what I'm going to do on the side is write down all the numbers from 1 to 25, and we're going to start crossing out numbers that have already been filled in. All right, well, a lot of these have already been filled in, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. All these guys have already been put in. We've also, the question has put in already 20, 21, 22, 23, 24, 25. So we only have, 10 numbers to actually fill in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. Let's proceed with this. So first, let's do the ones that are the easiest. And I'm going to start right here. 21 can only be made with the sum of its neighbors. And these are the neighbors. This guy, and this guy. All right? Well, we only have three choices. 20 plus 1 could give you 21, but 1 is not a neighbor. And I can't put 1 here. Why? Because 1's already been placed. So 20 is out. To get 21, that's not going to be useful for me. But 4, obviously. So 4 plus something has to equal 21, and therefore that x must be 17. So therefore this 17 I will circle. 17 guaranteed goes there. All right. Now let's go anywhere else. Is there some guarantee here? And I think in this corner right here. 25 has to be made somehow with its neighbors, and it only has 3 neighbors, this guy, and this guy. Well, the first two numbers, 9 and 24, when you add those up, it's 33. So obviously that's not going to work. 24 plus 1 will give you 25, but the 1's already here. So that means to get 25, I've got to basically use 9. 9 plus this number has to give me 25. And therefore that number has to be 16. It's the only way. So there you go. All right. So far so good. I hope, you're following. No problem, right? Now at this part of the question, we have to start, there's no guarantees anymore. Now we have to start fiddling around and using trial and error. And it's not too bad. Just stay confident and don't get flustered. If you put in a number, it doesn't work, no problem. Just try again. All right? So where am I going to go here? I'm going to try to concentrate on this region here. I know you think, well, the question mark's over here. Why don't you concentrate on that region? Well, because if I put something in there and it works, right, this area may not work. You see what I mean? I've got to fill in the entire grid. So if I can fill in this part and it works, then I know I'm in a great position to concentrate on the final part. Okay, so first let's look at all the numbers that are left, right? The ones that are not circled. That is going to give us a clue as to what we should put in the empty boxes. All right, so let's see here. This is what I want to concentrate on. Well, somehow I got a sum of 20, right? So how did I get a sum of 20? One of these neighbors has to add up to another one of its neighbors to get 20. Well, there's lots of possibilities. 21 is obviously greater than 20, so that's not going to help me. But 17 plus 3, but 3 is already here. Okay, no good. 4 plus 16, but 16 is already here, so that's no good. So 5 plus 15. It's the only way. So there you go. 5 plus 15 is the only way to give 20. So interestingly, that was another one that's kind of guaranteed. I thought I had run out of guaranteed ones, but I guess there was one more. But perhaps now is when the guessing game really begins. Okay, no problem. I think we should be able to figure out this corner here. All right, like I said, it's trial and error. There's nothing wrong with making a mistake. I'm going to try to put something in there. What number should I put? I don't know. I have no idea. Well, can I put in 19? Well, I don't think so, because if I put 19 there, because I'm just starting with, the biggest numbers that I have left, there's no way for me to get a sum, or is there? Right? Because the 15 plus 4, but the 4 is over here, right? And then 6 plus 13 could do it, right? That would work. But then what number goes in here, right? Because if you have that kind of a scenario, 6 plus 19 is 25, can't put a 25 there. 6 plus 13 is 19 again, so that doesn't work. Okay, no problem. Can't put a 19 there. Okay, if I can't put 19 there, what can I put? Let's try, let's try the other end, which is this end. 11? Well, I think so. 6 plus 5 gives me 11. That works so far. Let's go with that. We don't know, but that's what trial and error is all about. Now we get to the last two. We got to choose one of these remaining numbers to fit in there in this box, and then another remaining number to fit in there. Let's see here. 11 plus 6 is 17. Well, 17 is already here, so that's no good. Let's see here. If I put a 13 in here, 13 is one of the numbers that is still available. And then 13 plus 6 is 19. 19 is a number that's available. Okay, that all works out. Yeah, so I think I'm going to stick with that. So now what do I have left? 1, 2, 3, 4 numbers and 4 boxes. Okay, I hope this works. So 22 is there. So this number plus 2 can give me 22. Well, that number would have to be 20, and 20 is already there, so that's no good. So that makes me think that this number plus this number gives me 22. Okay, with the remaining numbers here, which two would add up to give 22? Well, my remaining numbers are 10, 12, 14, and 18. The answer is obvious. It's 10 and 12. But where do I put the 10 and where do I put the 12? Do I put the 10 here and the 12 here? Or do I put the 12 there and the 10 here? Right? That's a little bit of a dilemma. Okay, let's figure this out. If I put the 10 here and the 12 here, I will be able to get the 22. That's not a problem. But how will I get the 10? How will this 10 be made? Well, 2 plus 8, but 8 can't go there. 3 plus 7, but the 7 can't go there. So that 10 can't go there. So most likely it's a 12 here and the 10 there. Because 2 plus 10 gives you 12. So that fits perfectly well there. And then what about this number here? Well, 12's already gone, 10's already gone. Let's see here. 2 plus 8 is 10. 9 plus 8 is 17. 8 plus 10. 8 plus 10. There you go. That gives me 18. And therefore, there's only one number left, 14. And that must go there. And let's just make sure. How can we get the 14 with neighbors? 12 plus 2. That would give me 14. There you go. 14 is the number that goes in the question mark. So as you can see, it's a few guaranteed ones. And if I remember, the guaranteed ones were 17, 16, and 15, if my memory serves me correctly. And the rest of the diagram was sort of trial and error, trying to figure out how this will work, what fits, what doesn't fit. If I have an answer, which box does it go in? So as you can see, there's no 100% system. It's really trial and error, working it out. Don't get discouraged. If you get it wrong, no problem. Erase it and try again. So number 25, the answer is 14, and that would be choice C.